Hello everyone and welcome back. Apologies for any potential background noise in today's stream. I forgot to charge my earphone things, so yeah, might be a little noisy, but hopefully people can still hear me. So welcome back. Last time, where were we? We were just after getting to the point. Last week's session was implementing or finishing off the implementation for functions, which was quite interesting. I felt figuring out how scopes work, injecting parameters into the nested scope, introducing a rule for variable declaration versus variable assignment, so that we can, specify what scope a particular variable we're referring to is meant to be referencing. So today's session will probably be focused on kind of finishing off functions for the most part. Again, going back to a snippet that I had published before. In fact, do I have it here already? Let me see. So I have test. No, that's the file that I've opened right now, and test3. Whoops. No. Oh, responsiveness is a little laggy today. I'm not sure. Is that just connection speed? Not sure. But yeah, I'll just grab the snippet that I'm working from at the moment. In fact, I should put this into a new file. So this is so now that functions themselves are more or less working, there shouldn't be too much left in finalizing this last snippet or getting the last few bits in place for this snippet. So the two main things that it involves now are going to be first of all was support for functions themselves. So we've that implemented, and what we've experiencing quite an amount of lag today, I feel. So just for context, so I don't actually develop locally. I actually so my local environment, as you may or may not be able to see, in fact, if I do that, yeah, it's probably clear that my local environment is Mac OS, but I actually prefer, but then the environment that I'm actually developing in, eagle-eyed viewers may be able to see that it's actually an Ubuntu environment. So what I do is I've set up a Mosh server in a DigitalOcean environment, so that I can, basically, just for background context on this, I do like the stability and just not having to think about, setting things up and configuration that comes with the Mac OS environment and MacBook Pros and things. But I do not like the software of, like the actual software of those environments, despite how stable it is. So what I do is I run a Linux box in DigitalOcean, and I just connect to that, and I use that for some of my hobby projects. So got a few benefits as well. It means I can develop from anywhere, and I can run big expensive, well, not expensive, but computational heavy build processes on it, without my local fans revving up. So yeah, so that's why I might be experiencing a bit of lag today, though, and that's one of the downsides of it. But to get back to what's going on now, first of all, we have this operator that needs to be implemented. So in fact, that'll probably be our second arithmetic operator to be implemented. Another thing actually is, and I just realized that now, I haven't implemented returning variables from functions, so that'll need to be implemented. And then for this will be using higher order functions or functions as values. That's actually already, by nature of the way functions have been implemented in this language so far, we kind of get that for free. Just looking at this, we also have a range definition using integers that'll need to be implemented. And is there anything else? That's probably most of it. So if I was able to get all of this done today, that'd be quite a nice amount of work. But first things first, so I'll be looking at just implementing division. So let's take a look at that. So I'll rebuild the project. It looks like there was an error there, so I'll see where I am at the moment. And no, actually, so the error at the moment is just that it doesn't recognize this symbol because it doesn't support it yet. So what we'll do is, yeah, add support for division. So that will need to be added to the grammar itself and also to the AST. So let me just get my screen set up, and so where do we want to put this? This will be in expressions, and it'll be, do I have, so I don't think I actually have general arithmetic expressions just yet. I just have this plus operations equals. So I'll probably need to, but I have support for the less than operator. So this is possibly a good time to, so at the moment, yeah, once we start thinking about operators, we need to start thinking about operator precedence. At the moment, we have some basic rules of kind of what's this? I can't even remember the term. So it's like left binding or left association with operators at the moment. But so that's just kind of for this general Boolean operator. But when we start looking at things like arithmetic operators, we need to start considering things like, is it, there are different terms for it, but is it bomb das and those kind of rules for, if something, multiplication happens before addition, things like that, and dividing, breaking things down into factors and terms and things. Again, this is one of these things where I can never really remember the rules. So I'm just going to look them up. Compiler. So writing a compiler, let's see, factors. And let's see if there's any just quick references where they show the syntax tree you could be expecting. Maybe I'll try. Postmodern compiler design. I wonder what that's about. Let's take a look at some of these. So, PDF. So, yeah, so that's the BNF. But then when we're actually parsing this stuff, we want to to consider association and precedence. So is this sample? In fact, why don't I just do compiler operator precedence? Let's just try the first link. Whew, this looks complicated. Do they have a breakdown of that? Yeah, so pluses and okay, so the lowest level stuff has the highest precedence. Now this is just kind of a random log, so I'm not sure how legit that's going to be. So let's take a look at some other, and they didn't really have much there. In fact, yeah, this could take. Oh, here we have something. So it's really just parentheses are the highest precedence. Multiplication and things are second, plus and minuses are third, and then the lowest binding is the Boolean operators. And that seems relatively familiar. So I'll just go with that. But yeah, Booleans bind the least, and then parentheses bind the most. So let's. And now I need to encode that into this this format. So how do I do that here? So these are going to be the highest binding things again. And so these will be the lowest. Is that order correct? Probably. So I'll go factor, returns an expression. So I'll change these to factor. Unfortunately, this is kind of one of these situations where, again, I have a general grasp of what I'm meant to be doing, but not terribly able to explain what I'm doing. So that's still that. This will be changed to that. In fact, I'm not even sure if what I'm doing makes total sense, but I'll likely find out shortly. So previously as well, so I didn't even kind of, so we have this operator node in the AST, but because I only supported one operator, I didn't even store what type of operator it was. Or did I? Is this even being used? Oh, it was being used in the operator assign, but not in the operator node. So op plus. Don't think plus makes sense, does it? That would be add rather than plus, or sum. Yeah, I'll probably have to update some values here. So let's see, the operator here will be op, and I'll just call that div. operator here is going to be op less than, and am I getting a an ambiguity error yet, I wonder? No, no ambiguity issues so far, so that's good at least, I think. So first of all, need to address plus being renamed. I'll need to handle that in the evaluator as well. So that was called plus. Now it'll need to be called sum, and I'll also have to handle the fact that I have a new operation. And this will probably get a little hairy as well because no, that might be alright. Does Rust just let you do integer division? Yeah, and it probably just truncates the result, so that's alright. I was a little worried about that, but that was straightforward. And then in eval 354, so we take the operator as well, and this used to be you just do less than, but now it'll take the operation as a parameter. And so this new AST addition didn't quite cut it. I'll just put it all onto one line again, just to double check that it's the issue I'm thinking. So this is token 20. Oh, so it's oh no, it's the return is the issue actually in this point. So if I just did that, division is actually fine. The issue is fine now that I've implemented it, but the issue is that returning items isn't supported yet either. So let's take a look at how that might be implemented. So first of all, this is going to be a statement, and let's put it here beside beside function. It's going to take an expression and we'll add that to the AST, not the EST. I need to put some commas in there. And then just have to support it in eval, so that'll be interesting. So how is variable returning going to work now? So let's jump to, oh no, that's an old copy of eval. So line 45, so it's matching that, and so far we don't have support. So let's see. We have expression, and so first thing to do would probably be to just, is it a val expression? Yep. And we could just grab the v there, and it'll be evaluated in this current scopes. And then what will happen after that? So how do we handle this being returned? So this will have to be within the context of a function. And so how is a function, how are functions being evaluated? So also this is a function definition. And I'll just expand that here. And then we have a call expression. And when a call expression is evaluated, we evaluate the statements in it. And what we'll need to do here is add support for returning a value from an eval statements block, I think. Either that or write essentially a copy of eval statements, which will allow that as well. However, there probably wouldn't be enough of a difference between eval statements and eval, something like eval function body to actually justify that. Interesting. Anyway. Just thinking about correctness here, and I suppose, there are two potential approaches I could take here, possibly. So I could either do, I suppose, expand eval statements and update the definition of that so that instead of returning the unit type, that it returns a value, and then the caller would detect, okay, if this is returning a value to me, then it can only have been done via a return statement, and if I'm a function, then that's fine, otherwise I'll raise an error. The other option is to pass a parameter to the function to say, when running this function, if a return is attempted, then make a complaint because that's not allowed in this context. I can probably do one better by having the and so just to clarify, so I probably wouldn't take the second approach because it's kind of shifting some of the caller logic into the function itself, and while it would give us the correct behavior most of the time, we can probably achieve the same thing by instead using a wrapper function. So what I could do instead is, if the general behavior is to be like eval statements not in a function, then I could still have, in fact, I'll probably just type it up and show what I mean. So this is going to be the default behavior, and then in fact, if I just call it eval call, and eval call is going to return a value, and eval statements is actually going to be the same as eval call. though the naming probably could be improved. Maybe eval call statements. I'll have to work on that. Basically, the general approach will be eval call, and this value would be an option, and if it wasn't, if we got a value that got returned to us, then at this point we'd signal an error. So we could do something like this. Let's see, eval call. Bit rusty today. No, genuinely no pun intended there, but so I'd want to be doing something like that. And then, first of all, if it's an error, then I just propagate it. But then, if it's an actual value, I need to check what kind of value. So here we're saying if bad names, I know, but and so if we actually get a return value back, then it doesn't actually matter what the value is. At this point, we would be returning an error ourselves, saying that in fact, what does again, my reference language, what does Python do if I return outside a function? Return outside. Don't know what I expected. And we'll just say, we won't get too creative with that. Fairly self-explanatory. And then, so now so eval statements should now still work correctly for all of our other uses of returns. Eval statement now will also need to return an option, an optional value. And 9 times out of 10, this will be none. But in the case of a return, this will be V. So let's see. So that's doing if let error, but now we're going to have to change that to a match because we're now interested in positive values it could return. Maybe this could just be called eval statements prime. Again, not great naming, but I feel like it's better than eval call anyway, because it's not technically, I wouldn't call that evaluation of a call. But anyway, more mumbling. So at this point, if so basically, if we get a return value here, that signals that return was evaluated, and we short circuit a sequence of statement evaluations. Maybe I could call it eval block. I won't get too hung up on it for the moment. Anyway, what else needs to be done? So now that that's defined, like I said, 9 times out of 10 we're going to be calling eval statements, but in the case of a function call, we're going to use this special eval statements prime. Call. Maybe eval statements with return. Yeah, that's all right for the moment, I think. And so there's that. And yeah, I think the logic there is what I want. So now I'm just going to try tidying it up, getting it working, getting it running. Yeah, I'll have to update a bunch of these as well to return the correct values. In fact, this eval statement might be alright for the most part. So expect an option found value. Yep. Um, 135. Oh. What function is this in? This is in statements as well. So eval statements in new scope, that would probably need to be updated to return something as well. Or will it? Yeah, it will if it's being called by if with if statements. That complicates things slightly because then I'd have to create a wrapper function for that as well. Can that be put onto one line? No, I've probably tried that a bunch of times. Even though I'm breaking the line limit on a bunch of other lines too, so not too much of an issue, but and where is val statements in new scope being used? It's used in the ifs, in the while, in the for loop, and when evaluating a program. Yeah, maybe so what I'll do is just add the option value there for now. See where that takes us. It does mean that the names are slightly inconsistent because now we've eval statements with return, and this is doing something similar, but it's got a slightly different name. Unless I change this to eval statements without return, though it's, you're told, like, with return, I think makes more sense than without return, but yeah, what I'll do is, don't know what to do about that for the moment, so I'll just leave it and focus on getting the logic working. So expect an option there, yeah, and so you should. Line 51. Line 38. Expected so I can do it to string. Line 25, eval statements, expect an option but found an empty, so that would need to be with return. And got an option there. Can I evaluate this not in a new scope? Like the comment says, might make my life a little easier. So if I said that scopes was empty, I gave it the global frame as the inner scope, How does the inner scope work again? How did that how did that whole thing work? What was in here? So create a new scope from that. I'm not loving how this is looking. Logic is a bit so. Yeah, and I still need that inner scope there as well because it's being called directly. Yeah, this is kind of muddied things up somewhat, I feel. Like it's compiling and I'm guessing it's working, but I'm not liking how the logic is laid out at the moment. Yeah. Anyway, so what I'll do for the moment is I'll just carry on and I can always refactor the logic later. So where are we seeing an issue? At character 25 and the return value. Wonder what that is. What's our... Oh, because all of these actually put the semicolon after. Actually, so I'm just realizing now as well, my commentary today isn't exactly top of my game. So what I might do is I'll probably stay relatively quiet for the most part unless it's absolutely necessary for me to comment. As is the case here, where I'm getting an error, so I need to figure out what's going wrong here. Well, first I want to check out the error that I've gotten earlier. So if I go that I added earlier, and just check that works. Yeah, nice one. Return outside function, and if 1 equals 2, no, if 1 is less than 2, then I should get the same thing. But then if I try that, then it should error out at the next. Alright, yeah, it works, but not given the correct result. So how do we give it the correct result? So I know I'm returning value null somewhere. Okay, yeah, that would be it. So so here what I need to do is do a match instead. I have a guest.
Yeah, so where are we now? So this is going to be, this is an interesting part actually. So in this case, yeah, so we're still going to have the opportunity for the value to be null here, but it's going to be dependent on what actually got returned. So so in this case, what we're going to do is, now that the return is valid in this context, we'll check what it actually was. So if there was a return value, then we just return it. But if there wasn't, then we return value null. So we still have that case covered. So let's try that. Nope, that's a complaint. So line 433, expected a that, and same for there, and then 438 in eval. Cool, and now we have return values working. All right, so that's return values, and then another potentially neat thing is the fact that it should handle empty functions that do nothing as well. So that should return null. Okay, nice one. So that is that's return values handled. So I'll just add just store that. In fact, I'll undo the change to the test file. That didn't change anything. Or maybe it was like that before, was it? I don't know. Anyway, might just add a comment to highlight my distress at the current layout of the eval statements functions. Could I call it eval statements? No, I'll leave it the way it is for the moment. or maybe I will rename that to be without return. And say the default is that a block of statements can return a value. Oh, and that's the only, in that case, I might not even need a function for that. Yeah, where are the areas where val statements is called? All of these are val statements in new scope. So so maybe I'll just do that. And then I don't even need that awkwardly named function. Okay. Yeah, so it's really only going to be in the global context or the global scope or in the program context that this kind of an error can happen, because yeah, everywhere else it's going to be within a function call. So actually, yeah, that actually makes sense somewhat. And I'll just add the reason that this isn't the unit value. I'll just document that as well, because I think at first glance that wouldn't be obvious. Okay, I think that's about ready for committing. Okay. And so now that return statements are there, let's take a look. So then, oh no, that's not. So we need to go here. So yeah, that seems to be what we needed to do. So I'll take a look at the next chunk of work. So support for, and yeah, and I'll take a look at what result we get for some others of these. Yeah, that all makes sense. It truncates the integer during division. So so the next thing to implement is, well, like I said before, it should already have support for higher level functions out of the box. Now the issue here is that it doesn't have support for kind of ranges. And so this will be a bit of syntactic sugar to allow us to, oh, in fact, there are two things to implement here. So at the moment, I only have, do I have extended for loops? Where we iterate over, oh yes, so we do, we can iterate over, over lists, but there's no easy way of creating those lists just yet. So, so what I'll do is, so what's the best way of supporting this stuff? So we want to perhaps allow ranges in both directions. Do I bother with incrementers? For the moment, anyway. And are these going to be inclusive or exclusive? This, yeah, this syntax just leaves a bit to be desired, doesn't it? Hey, Jan Puntong, nice to meet you. Yeah, we'll take a look at what Rust does. Just to give us food for thought. So this, so it's inclusive to be exclusive, and then equals can be used. Oh, yeah. So equals can be used for inclusivity of the range of the ends. Yeah, me too sometimes. Me too a lot of the time, actually. Not being able to write code in existing languages. Still very much getting to grips with Rust as well. I'm having to reference it quite a lot. So So do I even want this this kind of a shorthand, or do I want to just add support for traditional for loops? Does Rust have support for traditional for loops actually? So it just doesn't, it seems. Oh, it doesn't have C-style for loops. Yeah, so I suppose if you want something more specific, like going up in twos and things like that, then you'd just have to write a while loop and do it manually, or define the range like using a map or something like that. Yeah, it's interesting. And I haven't, like, it's funny that I haven't actually noticed that in general while developing or while writing in Rust. That's very interesting. So now the only thing then is the syntax for inclusivity and exclusivity. Don't know this syntax. Would I just say that if you wanted to do that, then you'd have to add one, and it's always going to be exclusive, or yeah, exclusive. I suppose in Python as well, the range is just kind of set in stone. It's inclusive on the first element and exclusive on the terminator. So yeah, maybe it's just simplest to do it that way. And so if then I wanted 1 to 10, it'd have to be, oops, that. Yeah, so sorry, just playing around with different syntaxes here. Yeah, so maybe I won't complicate things too much here. I'll just say that it's just the inclusive starter and exclusive terminating value, and we'll just leave it at that. I won't think about it too hard. So this is going to be an expression, and we'll put it down with the lists. So this is going to be, oh, I might not be able to put it down with the lists due to a potential precedence issue, because if we're going to allow an expression here and an expression, so if this is going to be an infix operator, then that's going to cause us some issues. So what I'll do is I'll probably just put it up here as a low binding operator, and never actually checked the precedence stuff and whether we can actually nest these expressions. In fact, that's something that I should do just quickly before I move on. just briefly. So oh no, that's not the so comments in this language are like that, and they also comment out the rest of the file. So I have to put my print statement up here. So half isn't defined. Yep, but that's cool. So what I want to find out is, hey Kwan, nice to meet you. So is 2 less than 2 or 6 divided by 2? And so this should give me true if the operator precedence is correct. If the operator precedence isn't correct, then it'll give me a typing issue, because it'll be trying to divide a boolean by 2. Oh, thanks for the question. So writing a programming language basically in Rust. So the idea of the programming language is it's kind of a research language for, I'm intending to write another kind of more solid programming language after this, but the language I'm working on now is just kind of a mishmash of lots of modern language features, and then I'll be taking that and reworking the syntax later to figure out an ideal syntax for a language that I'm planning for later. Yeah. Thanks for the question. So, and what I might try and do here, actually, because it won't require me to change any AST stuff and it won't require me to change the evaluation, is to add support for parentheses. And parentheses can go around any expression. Yeah, so it's an interpreter. So yeah, infinitely simpler, and not having to use LLVM or anything. But yeah, but that has resulted in some of its own interesting issues as well, because I'm implementing it in Rust. It means I then have to battle against, I'm imposing certain constraints in my own language, and Rust is imposing lifetimes on it as well. So it's an interesting combination to do an interpreter in Rust. Yeah. Oops. So so then yeah, I think any expression can have parentheses around it. So we can do a string like string, and we can do a boolean, and we can do, yeah, I think that makes sense. Why do it in Rust? Very good question. I suppose simplest answer is I just was looking for an excuse to use Rust in a project, and while it has been challenging to work around some of its constraints, I do think that the final result is better off because of it. It's helped me catch a number of bugs already that I would have made had I been writing this in another language, I believe, anyway. So then, and even if I change the order here, so if I did 4 divided by 2 is less than 3, this should still give the true result as well. Yeah. But if I did something like this, that should give an issue, because it's going to try and compare booleans to integers. Yeah, invalid types for a comparison operation. Yeah. So thanks again for the question, Juan. Yeah, force myself to learn it. I'm yeah, it keeps making this stupid pun, but I am quite rusty at Rust. I use it occasionally, but it's not my daily driver by any means. So you know, it's a good excuse to just try and use it and learn the lifetimes and things. Though quite often, I basically just do what the compiler tells, and like fix my program in the way the compiler tells me. And what's my other language that I use on a day-to-day basis? Is it? Yeah, so I actually use Go on a day-to-day basis, which yeah, much lower, I would say, cognitive, not necessarily overhead, but I definitely don't have to think as much when I'm writing Go. I do think it has a number of issues then because of the lack of, say, explicit lifetime semantics and also the typing of it. But it's like I don't think there's a golden language just yet. I think Rust is coming the closest, but just in terms of raw kind of programming output, Go is probably the language I'm most performant in anyway. So that's my daily driver. Yeah. So yeah, just looking at the precedence rules, it looks like they're all working all right for the moment. So what I'll do is I'll try adding in support for parentheses as well. And so these will be one of the higher precedence um, kind of operations, I guess. And that'll I'll see if it's as easy to do as I just did that. Oh, I haven't tried nim actually. That's nim has a Python syntax, isn't it? And it's somewhat, I have heard it related to Rust. Does it have some kind of say concept of kind of lifetime and borrowing as well? Or does it? Can't remember. Rust like performance. Oh, very nice. Yeah, that's very cool. Though Python like syntax could be quite controversial. Rust like memory management. Okay, interesting. And does it? Because that's the thing. And is it strongly typed in that case? So do you have to specify types in it? Runs in browser and Node.js. Nice. And what kind of a domain would it be focused on as well? Is it so? I'm guessing if it's competing with Rust, it's probably running on, and if it's compiling to WASM, strong for static typing with UFCS. What's UFCS again? That's very cool. Yeah. I have heard a bit about name. It does get a bit of intention. Uniform function call syntax. Oh, is that like that thing in Rust where you can call a function, say without like you can, you know, oh, what's it called? Where you could, for example, call a function without any parameters, replacement of TypeScript and for Python too. Okay, interesting. Yeah, I still use, I still use a lot of Python, and it's only recently that I forced myself to migrate to Python 3 just because it's so easy to just write Python 2.7 when it's just installed on your machine. But yeah, no, it would be nice to have a nice Python replacement but with a kind of more uniform syntax and nice performance. Does it support parallelism actually and concurrency? I assume it must if it's the same kind of target as Rust. Oh, nice. Oh, interesting. It's really, yeah, it's really got a ton of features. Yeah, it's actually a language I know very little about, but there have been so many uh, kind of languages recently, I think. CTFE. Oh, there's a lot of acronyms there that I'm need to catch up on. CTFE, what's that again? Just going to do a quick test of parentheses here, and yeah, that's working. Parentheses are working correctly. That was quite straightforward to implement. Oop. Oops. Compile time. Ooh, can unroll loops, etc. that you can't do in Rust. As in, yeah, that's that's interesting. For better or worse, for something like that, that sounds interesting. I suppose the danger with compile time function execution is that I suppose if your compile time is then Turing complete, it means there's no guarantee that your program will actually compile. Very programming. Okay. Well, it really has kind of everything, meta programming via macros and templates. Macros work on the AST. So do you have function execution at compile time and macros kind of separately? Like, is there kind of a clear guide on when you would use one over the other? Oh, interesting. Wow. That's really impressive that everything has the same syntax. Nice. Like that's quite a feat because yeah, um I suppose it's easy to support all of those kind of separately. But to give a consistent look and feel is quite a difficult thing, I would imagine. Um okay, just putting it in a static block. Okay, interesting. Um yeah, that would be quite a straightforward way of doing it. That makes sense. Um, okay, so like you can declare your functions as pure effectively. And is there a benefit to performance to declare your functions as pure? Does that help with kind of inlining and things, or is it more just for, that it's going to help with parallelism and concurrency and things? Okay, nice. Yeah, that makes sense. Mm. Okay, so it doesn't actually track those kind. Yeah, because I'm guessing it doesn't kind of track those kind of mutations the way Rust does as such. Because I suppose it's an like I suppose just from what I gathered, Rust and the borrow checker do seem to be fairly unique. Oh, it does track it, so you can so it and okay, interesting. And so you can mark your things as pure, and so if it recognizes that you're doing a mutation, that it'll complain at compile time. Nice, that's interesting. Yeah, it sounds like it would be more lightweight in that regard. So you'd probably get a lot of the benefits, but with what sounds like a much more lightweight syntax. Oh, copy on write strings. Okay. Like, is that strings in general are copy on write by default, or really less verbose than Python? That's that's quite a feat because, like, I would say that Python is quite lightweight. Uh, in general, like it would be what I would go to for, a nice mix of, not having to deal with types and also not having to deal with, say, the, clunkiness of something like Bash or things like that. Yeah, Python is quite nice for the most part. I do find that at a certain critical point that, you know, I do start missing types, but it's definitely my go-to for scripts and quick processing and things like that. So just implementing range here. So this will be, I'll put this under list, and just a few things to do here. I have to make sure that the start and end are actually integers. So we'll evaluate the start and the end here. Can I pass that without taking the reference? I wonder. Also, it's actually quite a straightforward transition for Python programmers to learn in, is it? It is an interesting approach to use the Python syntax, I do feel, because it is one of the more controversial language syntaxes, it seems, especially the whole idea of indentation for defining blocks. Definitely not popular with everyone. It's kind of like the way Erlang uses Prolog as the basis for its syntax. But it sounds like it worked out in NIM's favor. I mean, if it gives it kind of quite a uniform syntax and consistency, then that's pretty cool. So now we'll just have to make sure in here as well that the values returned here are numbers, or are ints in our language. So I'll do a little match here. Oh, interesting. So it actually used to have braces and semicolons. And so, okay, so does it still, yeah, so if it doesn't have those, it must use the indentation rule. Okay, very interesting. So it was actually popular enough that that they just enforced it for everything. That's very interesting. Yeah, it shows different I suppose camps that people can get behind. Everyone chose to omit the semicolons, is it? So that means they use braces, or it's that if you have an if statement, is it the end of the line kind of signals the start of the new block, is it? Or not really sure how it would work without the semicolons. Oh, sorry, I'm thinking about colons, the semicolons. Okay, yeah. Interesting. Yeah, it does seem to be a modern thing to omit semicolons in general, and that's something that I want to do here eventually as well. Again, kind of Go style as well, but that'll probably take a bit more thinking than I'm currently able to do. I know that Go does some kind of intelligent, like behind the scenes, it actually inserts the semicolons for you. So I wonder if I'll use a similar kind of approach here. It works fairly well in Go's case anyway, I think. But yeah, it does seem to be very popular. Similar with JavaScript, that you can write a lot of JavaScript without semicolons as well. I think some code, some JavaScript linters kind of enforce that. So matching V here, it will have to be a, let's see, oh, where is value defined? Enum value. Yeah, so that will have to be, and do I have another section where I check types as well? Yeah, so whoops, what did I do there? So I have to make sure that this is an integer, and if it isn't, then range terminator or range end. Whoops, I'm misclicking a lot. Must be an integer. An integer. Integer. I can spell again. So return v, and then same for the start. Oops. Again, not the best variable names. I'm shadowing my variables all over the place, which could very much come back to bite me later, but with UFCS, any function is directly chainable. Input data, do this, do that. I'm not sure I follow that. So every function, Yeah, I'd have to look into that. That doesn't make too much sense to me. So is it every function returns? Yeah, so that's kind of like I think there's a similar concept in Ru or in Ruby where if you have a unary function, then you can actually call it without the parentheses. Like it looks like a just a property, but it's actually calling a function behind the scenes. I I thought that was UFCS. Is that kind of? I think C sharp might have something else like that as well. So is UFCS the ability to do without parentheses, or is that just incidental? Is it something more than that? Um, oh, and we can actually extract the integers here as well, so that'll be nice. That will allow us to actually just use Rust's own range definitions. So I should be able to do some. So that should create an iterator potentially, which I might be able to collect into a vector of values, possibly. Oh, but I'd have to map. I'd have to map over those. Okay, so it's actually something distinct from that. I'll have to look into that. I don't fully understand the idea, but yeah, that's something definitely something worth looking into. I'm definitely quite interested in the number of features you mentioned there because I suppose there have been so many languages coming out as of late that it's very difficult to keep up. But I have heard a lot of things about NIM. I've also heard about, I think Zig is another popular recent language that, again, just haven't had time to look into, but similarly seems to be very popular in those kind of spaces. But yeah, must look into NIM. It definitely looks interesting. Um, oh no, this shouldn't be an expression int, that should be a value int. And this also should, so we'll create the range here. So create a value integer around n, and then collect those up. So I think this is what I'm wanting to do. And then I return a list of x's, which is the range. So I'll just take a look at the compiler, see what I've done wrong to try and fix it. So line 350, I've probably got my braces unbalanced. So what's going wrong here? 476. No, nothing there. So where is the mismatch happening? I assume it's being introduced with this this expression branch. maybe if I comment the whole lot out and then uncomment one line at a time. No, still getting the same issue. Oh, I did some kind of a mess here at some point from misclicking. So let's see if I can correct that. Oh, so I got rid of some code by accident. So I'll undo that. Okay, and so now I can get back to trying this out. So let's see, cycle detected in AST. What's going wrong here? A recursive type. Oh yeah. So that's. Whoops. I need to box up my types. Was that a link with info on the UFCS? Is it? Okay, I must check it. Must check that out after the stream. Very cool. In fact, I'll just open it in a little browser window to the side. Actually, yeah, of course, it has a playground there as well, so I must check that out at some point. Okay, yeah, very interesting. And it does remind me a good bit of Rust with the way it's even the way the parentheses are like somewhat optional in those different examples. That's cool. So mismatched type. So I must go back into the parser and actually put those values in boxes. Okay, and now we're back into the code. So on line 409, use struct literal syntax instead. Oh yes, that makes sense. And yeah, we're supporting a new type here. Yeah, we're gonna say can't bind to a range. Okay, so now what does that look like? So first of all, we're just going to try printing that. So let's see, 0 to 10. Is that? Oh, I was wondering what. Yeah, because I put it inside a list, but I didn't need to. It's a list on its own. I was wondering why that was happening. And go 0 to 9. Yeah, because that's what Rust does by default, and we're using Rust's own implementation of ranges to implement our one. So That's cool. So then might be able to just run this as is. Well, we get some type errors here because we're not calling it correctly. Although there's an unrecognized token. Because I hadn't realized that I haven't implemented list indexing yet. So it's funny the things you forget that you haven't implemented. So what I'll do is, for the moment, I'll just print out the result of calling f on I. It's a bit of a silly one, but we'll try that out, and I'll grab the snippet so that I have the syntax correct, or the call syntax and parameters. And so unwrap on error value unrecognized end of file. Oh, because I have no semicolon there. Length isn't defined. That is correct. So that's something else that I need to implement. So let me think. Yeah, so I might as well just implement that. I think there are going to be some built-in functions. So in fact, I have one implemented already. So let's do something similar. So that prints the value, and this is going to do a match. Where is value defined? It's defined by eval. Okay. And so it's going to match on v0. Now that could panic, so I need to handle that at some point. So value, so if it's so we'll just start out with implementing it for a list, and we've got x's, and if it's x's, then we return OK x's length, and that'll be a value int, where n is the actual value. And then otherwise, it'll return error saying can only call len on lists for now. And so expected I64 found a U size. Oof. That's a tricky one. This issue I can just resolve with that. But here, let's see. Rust U size to I64. What's my best approach here? So it could do a try from, U size try from. Can just use int and nim. That would be nice. Borrow that. Not sure if this is actually what I should be doing either, but to do investigate casting usize to I64, just because I've done that. And so that was a bit of coding by coincidence, so I'm not entirely sure why it's working, but it does seem to be working. So what's happening here now? So this is saying for I in the range 0 to 3, because the length of x's is 3, print f of I, and f calls the function half, so it divides I by 2, and I at the moment is just going to be these, the indices. So it's going to, in fact, if I print the value before the halving, it might make things a bit clearer. So first iteration will be index 0, half of that is still 0. Second iteration is outputting is the index 1, half of that is still 0 because it's truncated using integer division, and then third loop around we get the index 2 and half of that is 1. So that seems to be working fine so far. So to finish off this snippet, I'll have to implement function or list indexing, both for retrieving items and for assigning items. Now, I'm not sure how, so the assignment part should be relatively straightforward based on the work that that we did on this a few weeks ago, but we'll still have to see how easy that'll be. So so yeah, the next thing to do is to implement list indexing. So let's try that. So first I'll look at the parser, and so this will go down here in the list section where we take at the moment I won't do fancy stuff with kind of slices and things. I'll just say that oh, this could be tricky as well actually. Will I be getting there could be some whatchamacallit, not conflict, but ambiguity here. Yeah, so I'll take a look anyway. So for the moment, so we'll just try this first. In fact, I'll just say we return the expression here just to see if there's an ambiguity in the grammar first. Yeah, that's an ambiguity. So maybe I'll have to put it up here in the section for lower binding. Am I still going to get an issue? No, that seems to resolve it, thankfully. So that does mean that this will be a lower binding item, but that doesn't really matter too much, I don't think. Or a lower precedence, I mean. So yeah, that variant isn't available yet, so let's add it to the AST. So we have list, we have range, and now we have indexing. I'll put that above range, or no, I'll put it below range actually. So, and because this is an expression within expression, I'll have to put it in a box too, and then index n is going to be a usize. So let's or it can't be a use size actually because it'll have to be evaluated first. Oh, that's going to be tricky too. But that's all right for the moment. So yes, those need to be all boxed up. So I'll just copy that index. That's going to be expression, and then n. Oh, what happened here? Oh, I need to get rid of that. And then, yeah, non-exhaustive patterns, that's all right. So I'll go into eval 37, and this will be actually, this is a nice bit because again, the work that we did before means that when we come to the assignment section, so where we had been putting before, we would say, oh, you can't assign to an integer, you can't assign to a string. At this point, we're going to be adding a rule for indexing. So it'll say, we will be able to assign to an index. So that's that'll be pretty cool. So that should be coming up in a few minutes. So first of all, we'll add in indexing. And we'll put that under range again as well. And we'll do a similar setup here where we evaluate the things. So this will have to be a list. And so we'll say can only, so if it's not a list, we'll say can only index lists. And then, so what I call this, this, again, my very bad names here in this project, because it is still relatively research phase, so I'm not holding myself to the highest standard. But yeah, let's put it like this, these names wouldn't fly in a code review anyway. So the end then will be replaced by index. Oh no, so that'll be n and that'll be expr. And so it's and then here we need it to be an int. And index must be an integer. And then what do we have next? So next we need to actually get the item at that position. So this will be an interesting part. So we know that so v at this point is a list of values, and index is an I64. So does Rust have just kind of a get or a try get or something? Let's see, Rust vec get. And so this will be values get index. So I won't distinguish between overflow or underflow or any of those kind of things. I'll just say, either it's a valid index or it's not. So there's no get. But there is here get index, and it returns an option, but it returns A slice index? Oh, because it can take different types, can it? And is there yeah, it just returns none if it's out of bounds. So that's more or less what I want. So let so that'll have to be a match as well. And I'll have to change that to a use size. I'm not sure if Rust will allow that, but we'll see shortly. And again, I'll comment it. If I'll put a comment there if it succeeds, that it's something I need to look into more. So values get index as use size, and if it's a none, then we return an error saying index out of bounds. And then if there's something actually there, then we return it. And in this case, yeah, we just return the in fact, I don't need to do that stuff. I can just take a bit of a shortcut here and just end it on that. I think 444 expected enum value but found interesting, found an address of the value, so I'd probably need to. That's interesting. So again, running into some of the issues with our Rust lifetime constraints. An easy workaround for the moment would be to clone it, but that'll mess up our references later, so I'll have to be careful about that. Also, I've been using format in general for these error messages to change them to constant strings. So if I look for toString, I can add a bit of consistency there. And that was the only one there. And then did I have another one in main? Yeah, I did. Format. And then 229. Yeah, this is the cool one. So now if we get an expression and it's an index, we say that, yup, that's fair game. You can assign to an index, no problem. So let's see. Expression index. So where did we have it before? So what will I need to do here? This will be interesting. So in this case, what happened before when we were, so we allow assignment to a list. Oh, and I had this special helper function for bind list. So I might need to do something similar for bind index, I'm not sure. So let me just take a refresher on what bind list looks like. Oh yeah, and there was special handling for the unspread list as well. And in fact, everything happened in here, didn't it? So made sure that the items were, the number of items were matched. Then it got all the left-hand side items. And then it went through all of the values in that and did a bind name on each of those. So if I do, so this could still be tricky enough, even though it's somewhat set up to handle it already. So where's bind name defined? Yeah, tricky enough. So let's see. So we'll have something like x's I equals v. So there'll be an expression here and the index there. So we'll take the scopes that we have. So what we'd want to do here is get x's out of the current scope and just update it basically. Is that it? Is that what we want to do? Actually, this isn't correct at all, is it? Because, oh no, it is. Yeah, so it's going to have a left-hand side. All operators are functions in nin, so you can have a function named brackets. Oh, interesting. Yeah, because say a number of functions have something similar where operators are functions behind the scenes, like similar to Python, where yeah, like you can have what's it? Oh, I can't even remember the operators, but yeah, you can have those. You can say what should happen. Say for indexing, you can define what an index operation does to a class, but it doesn't have. That does seem like a more straightforward naming convention. It kind of is more self declarative to say, you know, bracket equals. Only thing about that is somewhat less searchable on Google, but then yeah, I suppose if you're overriding operators, I think that's probably one of the lesser of your problems. But then that's only because I've shot myself in the foot with that a few times. So I'm sure more competent people probably don't have that issue. So let's see. So if we've x's I is equal to v, and I'll just call that n for the moment. Okay, so we have the right-hand side so far, and the right-hand side is just going to be assigned directly in there. And we can't necessarily look that up in the scope. This is a tricky one, all right. So I'll need to evaluate that. So actually that's where this kind of a thing diverges from the other types of binds, where in fact, yeah, where is bind being called? yeah, and the assignment statements and things like that. So the difference here is that with the values we've had so far, they've been kind of self-descriptive literals, whereas this is like indexing doesn't stand on its own, it has to be with something else. So what we'll probably just do, so I'll go back to the other definition of indexing. So I'll probably just evaluate the expression to get values, and similarly I'll evaluate the index. But then at the end, what I'm going to want to do is actually set the value. So it's going to be something like set index, and the RHS, the right hand side, is taken as a value here. The bind type, whether it's in fact, that's one thing that I'll have to check, is that the bind type can't be so we've two bind types. There is an assignment and a declaration, and when we're dealing with an index, we can't, you know, that there's a declaration in that context doesn't really make sense. So I'll prohibit that. I'll say if BT is equal to bind type declaration, and I'll probably have to derive equality to make that check. So that'll be partial equality, I think. So if BT is equal to a declaration, then I'll return an error in that case, because can't assign to index using declaration syntax. I'll just put that there for now. Probably could do with a little improvement. Now this is going to be the tricky area, and this was always going to be somewhat tricky, where we update update values, because again we're working around Rust lifetimes, and in order to do that we need a mutable reference to the thing that we're assigning to, and that's not really feasible here, and it might require us to basically put an arc mutex around everything, around all of the values that we set, and like that. Yeah, probably is just something we have to do. In order to get that working. Yeah, that doesn't mean that we lose all guarantees as such. You know, at least the interpreter itself will have some nice lifetime guarantees in itself, but insofar as the runtime of the language itself is concerned, yeah, it does mean we're not going to be able to reap the benefits of Rust's own lifetime checking. But yeah, that makes sense. So let's see, what errors do we have so far? first of all, mismatched types. Hack, yeah. Expected a result, but found a unit type. So did it expect? Oh, that was in here. So, oh no. Expected a result. Oh, just like that. Yeah. There's an associated function. Yeah. So values set doesn't exist. So we need to work around that later on as well. Line 250 expected an expression there, but got a box. Consider borrowing that. Yeah, I can borrow that. And yeah, so we have indexing working now. At least I think we do. But indexing, setting indexes will be a tricky one for next week because it's going to have to involve, yeah, using arcmutexes to work around Rust's own borrow checker limitations. So, our constraints. I keep saying limitations, but they're constraints. They're there for a reason. So, but anyway, let's just take a look at what. So it does mean that we can't do x's I is equal to f of x's I to half each element. But what we can do is we can still print the value. So first of all, we can print each value of that array that we got passed here in the second half. And we can also apply f to it. So we have first order functions. So yeah, so that works out as well as we'd expect. So so this maps the half function over 4, so we get integer division to get 2. Same for 5, we get 2 as well because the value is truncated, and then we half 6 to get 3 as well. So and then the result there is actually null because we didn't return any value. We could do return, if we return x's, then we'll get 4, 5, 6 because we're not mutating. And in fact, even if we tried to mutate, because at the moment the implementation basically just type checks everything but doesn't actually perform the indexing assignment. So if we do that, then the values just aren't affected. However, if we did something that's illegal from a type sense, then we do get a proper error. So it'll say, can't index, index must be an integer, can't be a list. And similarly, if we try to put I there, it would say something like can't index an integer. Yeah, it can only index lists. So the types are checking correctly even within the assignment section, but the assignment itself hasn't been implemented yet. So that'll be a task for next week. So what I might do for the moment is just to make a clean commit, I will basically just comment this section out for the moment. I'll grab that. In fact, yeah, there's nothing special there. Or there's that bit around the declaration check. So, and in fact, that's another thing that's neat. So if we if we do an assignment there but use declaration syntax, which we said was explicitly forbidden, then we get can't assign to index using declaration syntax. So we have to use the assignment version. So that's kind of neat. So what I'll do is I'll actually copy that out. I'll put it in a Scratch file for next week. And for the moment, I'll just say index can't bind to an index. And to do implement assignment to indices. Whoops. And, or, well, no, indices probably doesn't make sense in that context. It's probably assignment to indexes. I'm not sure. Too late for this anyway. So yeah, so that's more or less almost. So that's so just looking at the newest snippet. That's more or less everything. Oh yeah, Rust C is it it has sped up a lot, but it is still yeah, it definitely has a reputation for slowness. It does quite an amount of static checks, especially with the borrower and everything. So it's yeah, it certainly has a reputation as being a slow compiler. So but yeah, in terms of implementing all of this stuff, basically the only thing that's left is this index assignment, which we were going to have to face at some point anyway. This idea of, say, assigning to kind of references, which we'd need for implementing kind of objects or maps at some point as well. So yeah, so next week I'll be ripping that band-aid off, and yeah, it'll probably mean having to just have a very liberal application of arc mutexes everywhere. But yeah, that might just be what has to be done. So yeah, that's more or less it for me today. I got a good chunk done. So just to recap, got division implemented. There was something else around here as well. Oh yeah, returning values from functions. So that was pretty significant. Implementing ranges of integers for lists so that we can iterate over them, and index retrieval. So I haven't gotten to index assignments just yet, but retrieving values out of lists is the first half of that. So yeah, pretty nice amount. So in fact, I'll just commit that now, just so before I forget. So let's take a look. Git status, git add p. Oh, I didn't split this up into. I should have implemented range and indexing separately, but they're too close together. Oh, and I should have implemented length as well separately. In fact, I'll put that on its own at least. And I will commit that on its own. And add implementation for built-in len function. Yeah, they're just right beside each other. Or maybe I will split them up. Yeah, maybe I will actually. So I'll just reset head there. And I will do something very silly and pedantic, but that kind of describes me in a nutshell. So so I'll remove that. And that, and index. So then that should work. There'll be token errors, yeah, but at least the thing will be compiling. So then I can maybe I'll do that on its own as well. Use format for rendering errors, or just one error. And yep. And that is add support for range. What do I, whoops. Expressions. And then I'll add back all the things that I removed. And commit them. Oh no. I don't need the partial equality in this commit. Yeah, that still works. F string. Yeah, I know Rust has tons of stuff around strings that I don't understand, but I haven't heard of F strings. What's that? And so that is commit, verify, and add support for index retrieval. Nice. Like in Python. Still not following. Is that F string? Is that no? Still not following. Is that where you do ranges? Is it or? Like where you can do ABC 1 to 3. Like, yeah, I'm not sure what F strings are. Oh, right. Yeah, Rust has really nice string formatting and does tons of compile checks on them as well, so it can check the types of the variables involved, that they're correct. It can check that they're being formatted in the correct way. And that's one area where Rust is really nice, in my opinion, especially with the format specifier. So I'm probably using it somewhere. Just undo all these and format. Let's see. Yeah, you can. I think you can use it in most of the usual ways as well. So you can leave the braces empty. You can probably put a 0 in there. You can probably put a name. and you can also do things like this. So you can so if you have your own types as well, you can give them this special trait that's automatically defined, and it's like that's an automatic rendering that it can do, so that it outputs in a debug profile. But then if you want to output it as a regular string, you need to define that yourself. Yeah, especially coming from the likes of Go, where the printfs are fairly like, I have to say, they're fairly primitive. They're just C style printfs, really, without much special about them. Compared to that, Rust kind of blows it out of the water, I think. But then I haven't taken a look at Nim's ones either. Nim could have some very cool stuff around that too. But yeah, anyway, thanks very much for joining in, and thanks, Juan, for all your questions and comments and things. Very interesting to discuss. Nim, I'm definitely going. I'm going to have to take a look at that now. There are a number of concepts there that sound very interesting to me. So even if I don't end up using it, it's nice to kind of keep abreast of all of these kind of developments and things like that. So yeah, thanks very much for joining in, everyone, and I hope to see you again here next week. So thanks, enjoy the rest of the weekend, and take care.